More than 60% of industrial motors used are at least 10 years old. And while many are in good condition, older motors are less efficient than modern motors available today. Most older motors operate direct online, or DOL. These three-phase AC motors control speed and torque through mechanical means such as gears and brakes, and control flow and pressure with valves, dampers, and throttles. If these motors are not operating at 100% capacity, energy is wasted. Today, energy management is on everyone's mind. We want to use only the energy that is required for the system, nothing more, nothing less. There's a shift in today's motor systems, and that's moving from DOL to variable speed operation with an inverter duty motor, paired with a variable frequency drive, or VFD. VFDs control the frequency and voltage of the electricity that's fed to the motor and the equipment it powers. By removing the mechanical means of speed control, a motor system controlled by a drive uses 40 to 60% less energy. However, certain issues are presented when energy is controlled through a drive versus directly. In a DOL three-phase motor, the sine wave is perfectly balanced between the three waves in frequency, phase, and amplitude, and the sum of the three phases always equals 0 volts. When we introduce a VFD to control the energy fed to the motor, the energy from the power source goes through a rectifier, which converts it to DC power. The DC power is then fed into a capacitor inside the drive to smooth the electrical waveform to provide a clean power supply to the next step. Power then flows through the capacitor to an inverter that changes the DC power to the output AC power that goes to the motor. This step allows the drive to adjust the frequency and voltage applied to the motor based on the equipment operating demands. When motors are controlled by a VFD, the power is converted to a series of high-frequency pulses that emulate the approximate sine wave, but is not exact with high harmonics. The result is an imbalance known as common mode voltage. Common mode voltage builds up across the bearings due to the dielectric effect on the bearing grease and will eventually discharge through the bearings in what is referred to as EDM, or electrical discharge machining. Over time, this continual arcing will cause damage to the surface of the bearing race, resulting in vibration and heat, loud operating noises, and eventually motor failure. Fortunately, there are several practical and easy ways to mitigate shaft current issues. Using proper VFD cables and bearing protection will help protect the life of your motor and driven equipment. Bearing protection from shaft currents can be done in a couple of ways. Shaft grounding brushes, similar to the carbon brushes used on DC motor commutators, have been in use for more than 100 years. Brushes provide a low impedance path from the rotor to ground so that the shaft voltage does not build up to the point where it discharges through the bearings. However, the brushes are subject to wear because of their contact with the shaft and will eventually need to be replaced. Bearing protection rings also mitigate shaft current issues. They use multiple strands of electrically conductive fibers arranged inside a ring that goes around the shaft. They can be mounted internally or externally to the inverter duty motor. The ring remains stationary while the brushes ride on the surface of the rotating motor shaft, directing the current through the brushes and safely to ground. As with grounding brushes, protection rings will need to be replaced as they wear out. Bearings made from an insulated, non-conducting material such as ceramic are another solution to eliminate the discharge of current through the bearings. Non-conductive ceramic materials prevent shaft currents from flowing through the bearings and damaging the motor. Since no electrical current flows through the motor bearings, there is no chance of current-induced wear. However, the current will seek a path to ground, which means it will most likely travel through the driven equipment. Since ceramic bearings will not remove the current from the rotor, only specific applications such as direct drives or equipment utilizing non-conductive couplings are recommended for motors with ceramic bearings. It is vital that the customer and suppliers work together to identify the most appropriate solution for their equipment. Ensuring the correct use of grounding and insulation will always be an important first step. Brushes, protection rings, and insulated bearings are just a few ways to mitigate bearing currents that can harm the motor and equipment. Including these preventive measures will ensure peace of mind and increase the reliability of your inverter duty motor performance. Contact your local ABB representative for more information related to motor bearing protection.